Hello, hackers. Let's get this rolling on my iPad. Come on. Almost there. Every single stream starts with me fighting with Twitch on the iPad. Either Twitch or OBS. All right. Stream starts with me fighting with Twitch. Perfect. All right. Question on Twitch immediately. Is that a projector screen? Yes. It's I'm going to be recording some videos for ASU Online over the next couple of months, and they expressed a preference not to have my video game shelf in the background. So I bought a projector screen to give myself a nice clear white background. Movie night over Twitch on the projector. It's a possible idea. Yeah, I don't have a actual projector yet. Other question, is there going to be a Q&A office hours for the auto vulnerability discovery? Yes. Yes, the Q&A will be on the 2nd, and then the office hours. I'll have my office hours on Monday for sure. I think I haven't checked with Connor, but I would imagine that it's similar for him. So it should be good to go. All right. Yeah, the lion image. Lion image is a good meme. All right, let's roll. Boom. Okay. Welcome to week 12. You're still you still survived, and actually most people are thriving. Hopefully. Of course, first things first. Let's roll into the meme review. Meme highlight. I actually found out that PewDiePie used this idea of a meme highlight in his stream. How crazy is that? He calls it a meme review. Anyways, that aside, let's talk about memes. So we have some good ideas here. First of all, a very modern meme, cutting edge from presumably the live stream of the true era of time for pwn.college. I experienced this yesterday, actually. As you noticed, I released the last lectures at 8:45 a.m. or something. That was a late night for me, not early morning. That was quite an ordeal, but we're getting there. We'll have one more lecture on race conditions released for some of the more advanced levels tonight, and that'll make up the whole race condition scenario. All right, some other good stuff. Moloch and Malik. This is good. I love this meme. This guy is great. I actually recently watched The Incredibles again. Good movie. This is great. The corrupted T-Cache. I hope that everyone has truly internalized how badly things can misfire if data that libraries think is trustworthy suddenly becomes not trustworthy. And of course, in a lot of ways, Baby Heap is intro to linked lists, right? It is thinking through the implication of all of this stuff being linked lists in memory with no verification or little verification. All right. Let me hide my camera for a second to focus on this meme. This is pretty good. Baby Heap maybe wasn't... I mean, if you look at the relative difficulty of Baby Heap compared to others, it wasn't the toughest module there, but you should still be proud for doing a great job. And of course, a lot of people were talking about how, the push through Baby Heap constitutes what is apparently Type 3 fun. I didn't know about Type 3 fun, so it's good to add a new fun category. It's pretty good. Let's see. On Twitch, someone's saying, starting to feel like the only way to make a secure program is to not write a program. I think that is one of the big takeaways from computer system security, is that computer systems are not secure. Every little mistake, and now you've seen how many opportunities there are to make these little mistakes. Every little mistake can have crazy consequences in terms of security. I'm glad someone caught my my reference to the PlayStation 3. This was, back in the day when I was extremely invested in the console wars. I won't take a side publicly, but you can probably speculate what side of the console wars I was on. And then moving onwards to race conditions. Race conditions are gambling. There's going to be a huge amount of chance of getting lucky with the timing. It's going to be a very interesting sort of module. I'm really looking forward to see what you think of it. Yeah, Twitch. That's exactly the side of the console wars I was on. All right, and of course, this whole course is Intro to GDB. It still remains true that 90% of questions about the course can be answered by, did you trace it in GDB and see what's going on. All right, so let's bounce on two very important memes that I'll call out separately. Teaching evaluations are open. I'll bounce the camera so you can see both memes. Of course, I modified them slightly. Your voice matters, right? So just like I badgered you to go vote up until 2 weeks ago, now I have to badger you to go evaluate. So teaching evaluations are extremely useful for us to understand, are we making this course too easy? Should we make it harder? Right, last year that seemed to be the takeaway, and as a result, this year maybe it's still too easy. So please let us know in the teaching evaluations. Also, just in general, how we did. I'll also be sending out a more Pwn College specific survey to everyone that is active on the platform, not just ASU students. Of course, these teaching evaluations are for ASU students, but we'll have a separate thing for everybody so that we can get feedback per module and everything. Of course, teaching evals are generally like, how well does this professor convey materials, etc., etc. But please fill this out. If you have feedback that doesn't fit there, all feedback is useful, including filling out the survey we'll send out, filling out these teacher evals. These teacher evals are critical. Please fill them out. It's a very important part of the tenure case. No matter, if you liked it, you didn't like it, just fill out the teaching eval. It's all very good information. And even if it turns out I have the worst teaching evaluations in ASU this year, that actually is an opportunity to improve for next year. So it's not a case of, if you have nothing to say, don't say anything at all. If you have anything to say, if you have nothing nice to say, don't say anything at all. It's not like that. If you have anything to say, fill out those teaching evals. All right, let's see. Yeah, so the consensus on Twitch, a vote for Jan is a vote against democracy. I like that. And class was too easy. Yeah, that's exactly. Yeah, I am not tenured. I am starting my 4th year, I guess. This is my 4th year of being at ASU. The tenure process happens in the 6th year. I think you submit at 5.5. So yeah, exactly. Evaluations are important. Also, not just these evaluations. If you feel that, again, there's not enough, opportunity for feedback there, rate my professor. Even if it's bad ratings, those are all very useful, right? Very useful feedback for me to improve too, and also improve the course. Otherwise, we just do random stuff, and you end up with Jan 85. All right, and keep an eye out for that. Survey if you don't want to put feedback publicly somewhere. All right, rolling onwards. CTF report. So the number of CTF players is dropping slightly. This makes sense. I think a lot of people are getting kind of overwhelmed with the semester and other courses, but hopefully we'll see these numbers go up more. This past weekend, 10 students played a bunch of CTFs. I think one team played like 4 CTFs, which is kind of crazy. I don't know if it's something that I would necessarily encourage as a strategy. I think probably the thinking was there would be more introductory challenges spread out across more CTFs, but it's also more things to adapt to, right? So I don't know how well that as a strategy is, but yeah, it's interesting. Boston CTF turned out to be extremely difficult. Basically, across all of 466, I think I saw in the write-ups only one flag grabbed from Boston CTF, which is very interesting. There's a tough as nails CTF. The previous weekend, of course, we've had a couple more students play, or one more student. So it's we still have a good solid core in the course playing CTF. Next weekend, there's a bunch of CTFs. As you can tell, the most popular is Dragon CTF. This is hosted by Dragon Sector, one of the top CTF teams in the world. They're mostly Polish, although spread around the world. Pretty elite people. Should be a very good CTF. There is some talk and Twitch about ASU Masters program. Yeah, ASU does have a Masters. One thing that we're looking at next year is actually splitting up. Someone else mentioned that pwn.college should be 4 or 5 credits. We are looking at making it actually 6 credits across either session A and B, or of one semester, or 2 different semesters, where the second part is like a graduate level class that people that do well in the first part can take. I don't know. We're still tossing that around. It'll be an interesting sort of thing. All right, moving on. The leaderboard. This week on the leaderboard, there's a cluster of ASU people in the top 8. That's super impressive. You're up against some real super elite people around the world. So holding on to that those spots is pretty cool. But I will also encourage all of these elite people from around the world to keep pushing onwards. Take that top spot. Challenge the ASU establishment. I don't know. Anyways, I think that didn't meme out as I had hoped. Anyways, all right. So, top spot this week. Root. Congratulations, Root. I think this is the real Root because they ponged me on Discord or Slack or something to brag. Good job. Freak Mod drops to 2nd. Neural dropped to 3rd. But we still have some kind of very familiar heavy hitters. O1, Torashulk, Wodioi, Shadow, and Narnix. I think they were all in the top 20 last time. And then we got Hacks moving up the ladder. Now, of course, you know, the top 18 are all tied with 100% completion. Shinj and Hollow Circuit. Of course, we're used to see all these. Now Pointer again. MK, MSM 65536. It's due to the 16th. Janitor Joe, Blue Shirt Jan, Zero, Trishul. Is this the same 20 people fighting it out? Oh, yeah, I think so far. Ayayorn. Oh, it's Aaron. I know this. Okay, cool. Aaron and Flynn. Oh, Flynn is... Nope, Flynn... Wow, these are the same 20 people rearranged. All right, so good job locking down that top thing. All right, hold on, guys. I'm seeing in the chat someone saying CTF.pwn.college is the non-graded instance. That is not quite accurate. CTF.pwn.college is last year's instance. Please don't go to CTF.pwn.college. Go to CSE466.pwn.college. CTF.pwn.college has like obsolete challenges and is lame. Go to CSE466.college. You don't have to be an ASU student. Sign up. Do those challenges. Those are the new, fresh challenges. Like race conditions and the kernel don't even exist on that old one. Here, everything is... Oh, Narnix is new, someone is saying. How did I miss that? Wow, Narnix flew all the way to 8th. Yeah, from 19th. Awesome. But still already an old hat at this point. Everyone not in the top 20, let's give these hackers a run for their money. You can easily make it there, and I'll give you an incentive in a second. All right, so let's take a look at how this module worked. The way that we have things sorted internally, the kernel is always the last challenge, the last module, but of course we reordered that because of one of the extensions we had to give. Anyways, so baby heap is right here, so we can see baby heap falls somewhere between toddler 1 and the kernel in difficulty. Baby ROP seems to have been easier. But this is also actually including people that go back and make stuff up, right? So that graph gets pushed up over time. Let's see. If we look here for the grade distribution, it looks like, let me shut off the camera. Again, this is baby heap. So there were a lot of people that weren't solving anything in baby heap, and then unlike baby kernel, it's more of a smooth spread. So it looks like people either really got it and got to that A+, or the big spikes are A+, B, and E and D for baby heap. I didn't look into, what point, like which levels those would have been stuck on. But we'll look at it after the fact to try to smooth out the difficulty curve with, kind of more inner levels that bridge the gap between other levels. All right. Current grades. Let me move my video over here. All right, so we again started the class with 209 students. We have 118 still registered. That's down 1 from last week. 110 still trying. Oops, this should have been baby heap. My bad. Which is up 2 from last week. So people are getting back into it. This is super awesome to see. The curve remains the same. The changes we had, obviously this is uncurved and this is curved, but let me pull up, yeah, here we go. Let me pull up, this is last week's grades, and this is, so we had 11, 24, 39, 23, 9 in terms of grade distributions. We had one person move up from an E to a D. We had a couple of people move from an A to either an A plus or a B, and then a couple of people down to the C. So the heap was a little harder on people than the kernel was, but there was I think the curve still makes sense. We're going to keep it like this for a while. As a reminder, I won't make the curve less generous by more than 1 percentage point a week. I don't actually see it changing much throughout the rest of the course, but if we need to adjust it, we will adjust it. All right. So if you are not doing so well, what do you do? One, again, I'm going to keep saying this. Don't forget that the teaching challenges count toward your grade. If you didn't realize that and that impacted your grade, let us know. We'll try to find a solution. Don't panic. Go back and make up challenges. I saw a lot of people doing that this week. I think that's why, Baby Rop and some of these other ones that were originally on the harder side are now being more and more solved. This is awesome. Collaboration rooms remain open. Collaborate to your heart's content. Get those grades up. There's still CTF extra credit, still 4% of extra credit on the table. There's still the Y grade option if you need it. And, of course, because of Veterans Day and having to modify the schedule and push things later than we would have liked, the final module, Automated Vulnerability Discovery, is going to be an extra credit module. Right, let's take a look at this new schedule. Here's Veterans Day, 11/11. Then 11/18 today is race conditions. That's going to be graded normally. 11/25 is going to be complex exploitation scenarios. It's going to be graded normally, but it'll be open until the very last day before grades are due for full credit. We'll also launch at 11/2 Automatic Vulnerability Discovery. For extra credit, it's graded normally. It's just now your grade is divided by whatever, n-1 modules instead of n modules. All right. There's some questions about the curve. Let me back up to the curve. So the question is a 63% on, if you go to your grades tab on CSE 46.pwn.college, a 63% would be a C. Yes, it'll be between this 55 and 70%. But there's a lot of opportunity to move up, especially if you tackle both Toddler 2 and Automatic Vulnerability Discovery. And again, all of these we're going to have open. So the race conditions is normal, stays around for 1 week. Complex observation scenarios is normal, except for it stays around until the very last day of the course. That's, to make sure you don't have to give up your Thanksgiving. And then Automatic Vulnerability Discovery is also normal. It's extra credit. But realistically, what we're essentially doing is giving you one of these modules as extra credit, the way the math works out, right? We just divide by whatever, 12 instead of 13. All right, question about how does rounding work? We round typically to the single percent, so 98.89 would be a 99, and I think that will end up, with an A+. Okay. Now, there's a lot of extra credit, so why should you bother doing everything? Well, one, that sweet spot at the top of the scoreboard. I think there are a lot of people in this class that are pushing not just for their grade, but for the glory. And so we thought, how do we make that even sweeter? We often describe pwn.college, in fact, on our very website, as a first-stage education platform that will take cybersecurity white belts and train them to become cybersecurity yellow belts, right, in a martial arts setting. And so if you're thinking, why not make that real? And in fact, we're going a step beyond, right? We have Toddler 1 and Toddler 2. These are massive steps, right? In Toddler 1, you know the basics of security. In Toddler 2, you are now an advanced hacker in some sense. So you brought your own white belt conceptually inside your mind. If you get 100% completion through Toddler 1, we will give you a limited edition embroidered pwn.college yellow belt. And this applies to ASU students and not ASU students. We'll figure out how to ship it to you. If you get 100% completion, period, including automatic vulnerability discovery, Toddler 2, and everything else, we'll give you a pwn.college embroidered blue belt. And the yellow belt, of course. So, these are going to be quite interesting sort of loot. There is no time limit for this. You can finish it during the course. Obviously, that's the more badass way. But if you finish all the challenges sometime in March, you know, just shoot me an email and we'll get it sorted out. So yeah, this is going to be awesome. We're going to, and we're going to try to keep doing it. Again, ASU and non-ASU students, get those belts. All right, any question on belts or the general state of the course? Yep, we're giving out real belts. Yeah, if you walk around ASU with the belt, that'll be amazing. You should I don't know. We'll think of some cool ways to have like get the belts into a ASU culture. Awesome. All right. Hopefully everyone is excited about this possibility. Again, don't stress out if you've fallen a little behind. There's no time limit on the belt. If at any point you complete all of pwn.college, including the after we launch all the modules, obviously, you know, we'll give you that belt. Awesome. All right. Yeah, you gotta do Toddler 1. It's critical. The hoodies is going to be a tougher situation. All right. So, race conditions. Hopefully you enjoyed the lectures. Hopefully you had time to see the lectures. Again, I'm really sorry it was so late. This has been a kind of a crazy week. But now we are, you know, rolling forward and are gonna hit Toddler 2. Not physically hit any toddlers, of course, but get to that module with awesome momentum. I'm actually gonna record those videos like tomorrow, so that we don't end up in this situation again. All right. A couple of things that I need to tell you about race conditions, and then we will launch race conditions. I realized that the videos don't really cover how to use GDB to deal with these things, or how to use strace to deal with these things. In fact, when I used strace in the, so I have just this ptrace, not even a race condition, just a multi-threaded binary. What's going on? Oh god. Oh, pthread. Pthread .c. These are just my normal threads. So we create two threads that just basically print stuff out, right? We run this. I've already compiled it. It just, boom, creates two threads. Each thread prints stuff out and terminates. All right, I briefly showed an strace. If you just do an strace of this guy, we see the initialization, right? So this is pthread initializing and etc. Or pthread, the binary, of course, called pthread, not lit pthread necessarily. This is the binary initializing, and then we create two threads. So here are the two clone calls: clone call 1, clone call 2. Before each clone call, this is setting up the first stack, the stack for the first thread. This is setting up the stack for the second thread. And then this appears, printed from the first thread. But we don't see, you know, the system call in strace. Why is that? That is because by default, strace will just trace the main thread of the process that you provided, right? strace does have a very cool argument called -f, which will trace all children of that program, threads and processes alike. And here we go. So at first, there's only one thread. The moment that it calls clone, we have now split into we've now split into 2 threads. So here is one thread, here's the other thread, here is that write from the main thread, which we would have seen before. Here's the write from thread 2. And here's the write from thread 1. All right. So we have, and you can tell by the process ID of each one, or the thread ID of each one. So this is thread, or this is the, so threads and processes obviously are the same thing. Threads are just processes that share memory space and a bunch of other stuff. This is thread ID 201593, and that for sure returns 201593. And then if we look at that same call in 201595, it actually got descheduled, and then it later got resumed. So this is the kernel saying, oh, you're done executing for now. I'm going to yank you out. We're going to put another thread in to execute on that CPU for whatever reason, scheduling reasons. But then when it resumes, it returns 201595. Cool. All right. So strace, that was all pretty straightforward, right? So we just do strace -f instead of strace. Uh-oh, my headphones are running out of battery. Aha. Hold on. I need to plug in my... I suspect that what happened is the AirPod charger died. All right. So that's for strace. What about for GDB? Right? GDB is tricky, and honestly, I will show you a couple of different capabilities, but I'm going to have to embarrassingly Google around because I realized I forgot to practice this ahead of time. And YOLOing is a little hard on essentially 1 hour of sleep. Anyways, so we have GDB of this pthread guy, of course. Let's see what happens when we run. Okay. Or actually, let's break at thread main. Okay, so we have a breakpoint at thread main, and then we run. And the breakpoint gets hit. And it switches to the appropriate thread, right? So if you put a breakpoint somewhere, GDB will do the right thing, right? When a thread hits that breakpoint, GDB will switch to the correct thread, and then you can, examine things just as normal. Here's that first NBR64 instruction, etc., right? Now, what if instead we want to break at main? Okay, here we are at main. And we want to step through this pthread create. What happens if I single step right now? Right now, I am in the main thread. If I single step, okay, let's finish executing. I end up in main as well, right? After the call in the next instruction, main plus 59. I was before at main plus 54 in the parent thread still. Now, what if I want to get to the child thread instead automatically, right? Wait. hold on a second. What am I saying? Well, let's try it. Okay, so I'll break at main. I run. Here we are at main. Okay. If we set follow fork mode child, I have a sneaking suspicion that I'm full of shit and this is just for forking. Sorry about this. 1 hour sleep is not good. Okay, so we're about to call pthread create. Next instruction. Okay. Yeah. We're in main. So that's just for forking. That's not for clone. I wonder... I guess I've never actually run into this in practice. I always just set a breakpoint at the main... at the entry point of the thread. So you can do that. I mean, that's probably the easier thing. Anyways, so if we can break in thread main, we can run. Here we are in the first thread. You can look at info threads. Yes, info threads. These are the threads that are that currently exist. You can how do you switch threads? Yeah, I think there's thread, and then you say I want to switch to thread 3, and now you're at thread 3. You want to switch back to the main thread. You're at the main thread. We can single step. Let's switch back to thread 1. You're in the main thread. You can single step from the main thread, and then it'll eventually get back into main. Let's finish that. Yep, and we're basically back in main on the single thread. So, pertinent thing, info threads. Now the other two are terminated, and then thread 1, 2, 3, etc. to switch threads that you're debugging. And breakpoints work as you would expect them to. Someone's asking what command line interface is this? This is GDB, just vanilla GDB, not anything fancy. Okay. My advice when you start seeing threaded applications in this homework, don't panic. They're just programs. It's not that much different from multiprocessing. They just mostly share memory and some other parts. Okay, anything else that we need to say about threads and race conditions? I think this... Oh, one more thing. I realized, actually someone pointed it out to me on Discord, thank you very much, that when I was talking about race conditions and I was talking about mutexes, I have a typo on this slide. This should be unlock, and in the source code it was unlock. I have no idea how that typo happened. This was 7 a.m. after no sleep, so anything can happen. I'm going to change it real quick live on camera. I'm going to change the lock to unlock. Boom. Then refresh this. There we are. Unlock. All right. So apologies about that. I'll add a note to the YouTube video, so people are hopefully not confused. Okay. Let's see. It is currently 5:09. We're 40 minutes into the class. So I think we launched the challenges at 6. Or earlier, whenever we run out of things to talk about. This was the very urgent thing I wanted to discuss so that you didn't feel panicked in GDB. Any questions about baby heap? Kind of rewinding a bit before we run in. Oh, someone has a question about race conditions. Perfect. Let's hear it. Yes. Okay. So the question was how to create file system mazes. So as a reminder, the file system maze is this crazy situation where there's a directory for the maze, and then there is a directory with a bunch of depth with a symlink going back to the root, and then a B direct, and so on. So how do we create this, right? Of course, oops, I didn't show the slide. God damn it. Here we go. Here's the file system maze. Very cool stuff. And of course it works because of what I'll show you. I'll show you how it's actually resolved, which is pretty crazy. All right, so here's our pre-created maze. Let's make a maze 2. Let's go to maze 2. What the hell? That's new. Okay, anyways, maze 2 is empty right now. So the first thing we want to do is create something, directory called a/1/2, etc. Right? Obviously, typing all this out is going to be a bit of a drag. Also, if you just use mkdir, you'll have to do it one by one because you can't do this. It'll say 2 doesn't exist. You have to. Yeah. This is really annoying. mkdir has a -p option flag. -p means make parent directories as needed. This is super nice because we can just pass in the whole thing. Okay, so that's one thing that makes it a little easier to find. Here's all of our directories that we created. How do we make this automatically, right? So we can go, there's a command called sequence, seq, that can just create, that will print out a bunch of numbers. So if you print out numbers 1 to 1,000, actually 1,000 with the backslashes might start getting to the path limit. Let's do 1 to 800. Right, just prints out all those numbers. There's another command called tr. tr replaces characters. We can replace every new line with a /. That's starting to look like a directory path. So let's save this to a variable. This is our subdirectories. Okay, and now we can do mkdir-pa/subdirs. Okay, and here it is. We have a/1/2, right? So this is one of our things. Of course, we can automate all this, but honestly, it's not that hard to do each one. We can sing the song in our heads. But how would we automate this? So we can also use sequence again. We can use sequence 1 through 26. We can use tr to replace all letters, all numbers. No, I don't think this will work. Sorry. No, it didn't work, obviously, because it's character by character. Never mind. There's obviously ways to automate, but we'll be I, J, K, oops, L, M, N, O, P, Q, R, S, T, U. Anyways, that's more than we're going to use. Tons of folders that each have very deep nested directories. All right, so now we need to create the root links to point back to the beginning. Here's what we're going to do. We're going to look at every directory. We're going to pipe that through. I like to use the parallel command to basically it'll take every line outputted by ls. When you pipe it something ls to something, it outputs each file on a single line, and it'll just run this command. So we can just echo that line, okay? And it'll replace this open, close curly with whatever it read off of the input. We can do our symlink. So symlink back to the maze of this line slash the subders. Oops, I made the symlink instead of echoing it out, but that's fine. So this is what we ran for everything. We ran ln-s, create a symlink to this maze from here. Oops, hold on. Let's remove those symlinks. Okay. Did you see how long that took just to remove 26 files? All right, /root. That's what I meant to do. Okay, so now if you look at A and then go into all of, oh, this is going to take forever. So if you do A/subders, there's our root. Okay, and it goes back to the parent. Now we need to make a link going forward into the depths of each maze. We can do that with parallel as well. So we ln-s into that, the depth of it, and then put in a end. So here we go, a end, b end, c end, d end. And if you look, each one goes to the very end of this maze. And then there's a root. And then in that root, it goes back to the beginning. So now we can do this crazy stuff. Remember, the Linux kernel will only allow you to follow, what's it called? 40 levels of system calls. This is, I think, a easy way to prevent just a recursive system call. Of course, you could have a symbolic links, 40 levels of symbolic links. You could have a recursive symbolic links that just go back to the parent directory, and your, whatever process that tries to enumerate all the files will get stuck, right? So the kernel will prevent this from happening by having a limit of 40. And of course we can create something like a path that is AND/root/BN/root/CN/root. Every time I'm doing this, it is going all the way through the A subdirectories, and then and then back out to the maze, and then all the way through the B subdirectories and so forth. There's an awesome utility called readLink that'll print out the resolve your link, resolve a path, right? So if you do readlink-m, canonicalize by following every symlink in every component of the given name recursively, and we do AND/ASDF. This is the actual path that the kernel will traverse when you do AND/ASDFs, and if you do AND/root/BN, it resolves it altogether. This is the actual final no, readlink isn't the right thing for this, but basically let's build this giant path. AN/root/BN/root/CN/root/DN/root EN/root/FN/root. And of course, each of these is 2 symbolic links. So we get up to 20 letters. The 20th letter is what? T. Let's do 10. All right. So if you look here, we're back in root, of course. Now, let me show you. So this is the same as doing ls dot, but I don't know if you notice on the stream, it's slower. We can time this, and it takes 0.125 seconds, a tenth of a second, to just do an ls. If you just time ls dot, it's nearly instantaneous, right? Of course, as we add more and more, so there's j and k and root, l and root. You might ask, why not just do AN/root/AN/root/AN/root, etc., just a loop? You can do that, but the kernel might cache these lookups. It all depends on the implementation. One sec, I'm going to turn on the lights. All right. So it's better to just keep it as varied as possible. Okay, lm and /root and /root. A fifth of a second. pn/root, qn/root. 0.3 seconds. I mean, you can see it, the system slowing down. /root. /root. Okay, we're still good. tn/root. un/root. Yep. Too many levels of symbolic links. U is the 21st letter. Yeah. So that was 42. Here's 40. Almost half a second just for ls. This is a massive slowdown, right? And it'll help you win things quite a lot. Okay. Did that help with mazes? Yeah. And so recall, this is the path that you will send to your to the vulnerable program. If it says, oh, give me a file name, you give it this file name, right? And then it'll, you know, and the crazy thing, even if it doesn't allow you to give directory names, of course you can symlink. Watch this. You can let's say here's some secret. We have a secret file, the root of the maze. You can symlink slow secret. Oh, sorry. Fuck. Sorry, that was a copy paste there. All right, let's. Here we go. You can do symlink all of this /secret, because all this goes back to the root of the maze, into slow secret. Okay. So you have two files. You have a secret file, access to which is instantaneous. And you have the same file, a symlink to the same file through the file system maze, access to which isn't allowed because that's 41 symbolic links. Hold on, we have to remove T from here. Okay. There is no R slow secret. Where do you see R slow secret? Why isn't this slow? Oh, interesting. I was expecting that to be equally slow. This somehow is not a slow access. The kernel must do something intelligently. But if you give it the full path, of course, through the file system maze, where's that time? Here, /secret. No, catting it is fast. Hold on, is it as fast? Okay, 0.7 seconds versus 0.1. Okay, it's still slower. It's just maybe ls has some additional slowdown. It's a bad example, but you can see if you time catting of slow secret, that takes 0.4 seconds, 0.3, 0.4. If you just cat secret, that's 0.1, right? So it's 4 times slower to access this symbolic link through the maze to that original file of secret than it is to actually access secret. Cool. Yeah, on Twitch, Connor saying that ls might be recursively calling stat on each directory. That's probably what's happening. That's probably why ls is so slow. But this is enough of a slowdown. This is a 4 to 7 times slowdown, right? So this iteration took 0.007 seconds on slow secret, 0.001 seconds. That makes a window 7 times as big. All right, Connor's curious about ls. Let's strace ls. Oops. No, it doesn't look like it. Oh, it is calling stat. Maybe just even the one stat is very slow. Oh, let's see if stat itself is slow. No, stat is super fast. Wait, but if you strace ls, it's super fast. I mean, not as fast as this, of course. Oops. Still 4 times as slow as... Okay, anyways, the point is, the file system maze slows down file accesses so that you can more easily win races on the file system. All right, any other questions on race conditions or the heap? There's a lot of conversation. People asking about 9. No, okay, 9. Talking about the unintended solution of 9. Could we go over level 12? Let's check out level 12. One thing. Okay. Launch up level 12. Open it up in Binary Ninja and download it. Wait, did I do level 12 in my office hours? Does anyone remember? I think I might have started in on it. Is level 12 the first one with echo? Oh, I gave a hint in office hours. Okay. All right. So let's check out level 12. So level 12 has let's just create. All right. Level 12 gives us malloc, free, echo, scanf, and quit. Malloc is our old friend. Gives us an index and allocation array, a size, and then mallocs it. Echo lets us take an index and an offset and writes it out. Free lets us free a page in the allocation array. So now that should have some data, the Tcache metadata. So if you echo index 1 at offset 0, it's not printable. Offset 1, echo index 1 at offset 8. There we go. Some printable data. So this is the pointer to the Tcache per thread struct. So we can leak stuff out, right? And if we look at, oops, the program, there's a win variable, right? Basically, we just, or win function. If we just get here, we win. Hold on. Okay. Oh, can't see terminal. Oh, God damn it. Did anyone see the terminal at all? Did I show the terminal in the end? Well, here was the terminal. All right. So using echo, by freeing an allocation, of course, that initializes that Tcache metadata, and then we can print it out. All right. So we need to redirect execution to win. Checksec tells us that it is position independent. Now we get to sit here while I have a brain fart. So what's the solution? Let's think. First, let's make sure that nothing got missed there. Malloc free. Echo scanf quit. NX and PIE. NX. PIE is enabled. So we can leak an address to, let's see what the addresses we can leak are. Okay. Okay. Okay, and now we will send echo 1 at offset 0. Read until data colon space. Oh, God damn it. Okay. It's fine. You didn't miss much. I'm just automating this. So this is, oh, of course, this is null. Okay, Tcache next. This is going to be null because I only freed one guy. So I'll allocate 2 things. Okay, so now the metadata 1 should be pointing at 2. So Tcache next is when I really count that metadata, p.readline. Then we'll do the same at offset 8. Per thread adder is this. Okay. Where did we fail? Read until data colon. That is correct, right? Echo 1.8 data colon. Okay. Let's see what happens. Unrecognized choice. Oh, oops. I used send instead of send line. Why isn't it? Oh, I need to quit. My bad. Thank you. Boom. Okay. Awesome. So here is our Tcache next. Let's cut off the new line. Unpack it. And I messed this up. This should be here, and then this is p.readline. -1. Okay. And this will be probably 2. Let's left justify it with null bytes to 8 characters. Okay. Here we go. 2 addresses on the heap, presumably. Very cool. All right, so we have leaked 2 things on the heap. We know where the heap base is, basically. I will bet that these are stable. Yeah, 16 DOA. All right, so this is a good start, but it's not enough. Let's see where else. What am I missing? This is such a interesting feeling. Oh my God. I went. Yeah, exactly. Thank you, Connor. So Connor saved me. I went through this in my office hours. Why is it echo and not puts? We could easily say, hey, you can give an index to puts. Puts can take an offset, or we can calculate the offset just as easily. But the way that we implement malloc, the way that we implement echo is very careful. We set up this execve call. The execve takes a string table, a bunch of pointers ending with a null byte, and we create this string table and malloc an allocation for this string table. Right? Now, of course, as you know, when you freeze something of a given size, the next malloc will return that something. So if we make our freeze here, make our sizes here 32 instead of 16, because that is because that is how big this malloc is. The fuck, come on. Okay. Now, when we call this echo, it's going to allocate into this, when we call this echo, it's going to malloc 32. That will get that'll allocate a chunk that has the address that is currently still stored as a dangling pointer in our allocation pages, right? And then, of course, we can echo from it. It'll be this chunk that we, here's the chunk, right? The chunk is going to have the string bin echo in its first 8 bytes. Bin echo is in the binary. It is specifically, I'm going to regret double clicking there. It's the base plus hex 4010. It's going to have this var16. var16 is just the word echo. No, it's the word data colon. So we can change this character constant data. It's going to have the address with the offset that we want printed out. And this address with the offset is going to be, wow, that's messy. It's going to be this arg1. Let's see where it's called over here in the echo. Have echo. arg1 is var 118. var 118 is no, hold on. Sorry. This is going to be a pointer to the heap. This is exactly the data we're printing out. This is going to be a pointer to the stack. It is the address of var16 where the string data is stored. So first word is going to be an address of bin data in the data segment of the binary. And then the second address is going to be a stack address. Let's take a look. So here it is. Echo 10. So this is going to be data address, the address of the data string. Echo address, the address of bin echo in the binary. Then it doesn't free that allocated pointer, so let's free it again. And then we'll do the same thing again. Okay. And now at offset 8, so this will be the stack address. Okay, and now let's print echo address, stack address. Here is the address of echo in the binary. Here is the address of the stack. You can see that's a stack address. Okay, we're basically there, right? Based on this address and GDB, I can figure out where the return address is, of course, and then based on sorry, my mind's going blank. And then based on this address, I can figure out where the win function is. Let's actually compute that address of the win function. Equals the echo address minus hex 4010, right? Let's take a quick look at Binary Ninja. 4010. 4010. Perfect. Okay. Plus the win address is, I'm looking at Binary Ninja, 1 hex 1358. Boom. So this, it's likely, I'd have to see, it's possible that the data segment is offset a little from binary, but this seems like a reasonable situation. Let's actually, instead of sending quit, let's do this. Let's do this. All right, here are the maps that we retrieved. Here is our address of win that we calculated: 55A4AA, 55A4AA, 0B 8010. Yeah, okay, we have it in the wrong offset. We have it offsetted into, if you recall how binaries are loaded in memory, first it loads the copy of the ELF with all of the executable stuff and read-only stuff for RO data and that text, and then it loads a second copy of the ELF with without mapping anything executable, but mapping things writable. So we need to subtract. It's going to be at one of these offsets, probably, obviously right here. So let's just subtract OX3000 randomly. I think it should work. We'll deal with it if it's incorrect. So this at least now is. Oh wait. Oh shit. No, I'm full of shit. Never mind. Ignore everything I just said. Win address. There we go. I'm printing the wrong thing. Win address. All right, here's the win address. EA4F358. Oh, it's perfect. It's in the executable section or page. It should be good. Okay, so we have the win address. We have the stack address. We can now figure out where that return address is and figure out where the return address is from main, and then overwrite it by creating an overlapping allocation, and then happily quit. Let's just do that while we're at it, since we're here anyways. Oops, I haven't been killing these things. p.send line quit. Otherwise, we'll have a bunch of them. All right, let's GDB attach here. Okay, here we are. Let's break at the return address from main. Okay, the return address from main. Continue. Okay, here we are at the return address from main. RSB is here. We are about to return into libc. Boom. Here's that address. Here is the address of the stack as we leaked it. So if we, oops, I copied both. If we take the subtraction, this will give us the offset we need. Oops, no, here's the stack, the real stack, my bad. That was a libc address I just pasted. So main's stack address when it returns, that where the return address is stored. This is the value we leaked. Hex 156. Is that stable? I bet it's going to be stable. Let's just double check just in case. Boom. Break at main. Continue. Here's the stack address right now. Here we are. Oh shit! That's the old leaked version. Here's the thing I leaked recently. Hex 156. Awesome. So basically, main return address equals stack address plus hex 156. Okay, so now I need to allocate a chunk that will go over main's stack address and allow me to overwrite it. Okay, this is nice and simple. Actually, I think this was kind of overkill. I can just create a gigantic chunk, but we'll do this. All right, so I know where main stack address is, or main return address. Let's say return RSP. This is the RSP at mains ret. All right, stack address undefined. What? Stack address. Awesome. Okay, cool. So, now let's malloc something of a very large size. I don't know, 128. Malloc it again, or malloc another one. And now we want to free 3 and then free 4. Oops. So now the count in the Tcache for size OXF0 is, OX80 is 2. And then the top one is this guy in 4, and he's pointing to 3. Now we want to scanf into 4 of our main return RSP. So we're going to override the next pointer with where we want the chunk to be allocated on the stack. But of course, this is going to clobber the 16 bytes beforehand. Will it clobber 16 bytes beforehand? It might not. Let's give it a try. The worry is this will clobber the canary, but let's give it a try. And then we allocate twice. And this second allocate, the first allocation will return what this had been. The second allocation will return a chunk pointing to main's return address. And if we echo that out, we can see oops, I forgot to this crashed. This crashed. Okay, so one person saying, hey, if you're just doing hex adder, don't I need P64? No, because this is scanf. That's reading. No, you're right. I do need. My bad. Yeah. Lol. Thank you. Still crashed. Let's attach HTTP. Question, does sending it on one line even work? I think it should work. This is printable. Why is R8 printable? God damn it. Yeah, do I have a repr issue? Ah, okay. Let's not do that then. Okay, I have a repr issue. Thank you. Okay, boom. Oh, whoops. I don't want the debugger anymore. Go away. It didn't crash this time. Amazing. All right. So now we should have just boom. We leaked out something that I bet is the libc return address. And let's make sure that. Wait, didn't I disable GB here? Yeah. Okay, cool. All right, so we leaked out. Yeah, this is the library address. Perfect. So this is the return address from main. So let's just scanf it. We're almost there. Scanf into 6. Return address of the address of win. And then we quit and enjoy the glory. Boom! There we go. That is the solution to 12. Okay. Awesome. What a wild time. Okay. So let's, we're actually right at 6 p.m. Oh, so there's a question on Twitch. Why is my example flag 31338? I'm doing this locally on my computer where, of course, I have a slash flag that is 31338. So there's no significance. It's just what I happen to have in slash flag locally. Cool. All right, so that was level 12. Sorry for having a brain dump partway through there, but we got through it. Let's take a break. Let's do a 13-minute break until 6:10 Arizona time, 13 minutes from now. And then, why pick that number on Twitch? Oh, it's 31337 plus 1. I had it at 331337, but I wanted to make sure that something wasn't giving me old data, so I changed it. I added 1 to it. It's a random number. There's no significance. 31337 is elite, of course. That is significance. Boom. All right, awesome. Okay, so 12 minutes. At 6:10, we're going to resume, and then we're going to sit down, launch the race condition challenges, the first couple, and then start collaborating and start rolling. See you soon. All right. Welcome back to race conditions. I got a frappe to get us through the rest of the class. It's going to be awesome. All right. Connor, where are we at? We're launching. Okay, we are live. Let's take a look at what just launched. Here we go, baby race. First 6 levels are up. We will launch more levels. I think we'll end up with less than or equal to 15. These will get you started with race conditions. All right. Let me, by law and by custom, walk through level 1. Launch it up. Hit that inspect. Download the challenge. Oops. Crap. Okay. Awesome. All right. So it is launched. Let's take a look. Here we go. Launch baby race. All right. Challenge allows you to open a single file. The file opened will be sent to you. The challenge will verify that the file's path does not include flag, and it'll verify that the file is not a symlink. Let's see what this all looks like. Here it is. Here is main. Let's grab that decompilation. All right, so it needs an argument. That's great. The teaching levels of this challenge are very unique because they make the race very explicit. What they're going to do just for the teaching challenges is where the race has to happen, they will actually stop and wait for you to press enter. All right, so we'll do flag. Right, Connor, why do we have multiple places where this blocks? Okay, so there might be multiple places where it'll wait, but here I give it flag, and it says error, path contains flag. Okay, so then I can do etc pass wd, and it'll block. Okay, so, god damn it. All right. So it didn't like when I passed flag to it. It said path contains flag. So instead I passed etc pass wd. It called lstat. So it says I will not follow symbolic links on the path. And basically lstat will check if it's a symbolic link. etc pass wd is not. Well, lstat does a bunch of things, but including lets us check if it's a symbolic link. And then it prints out the path, the file that I requested it to print out. Cool. So as you can see, this challenge in teaching mode blocks right after it does this lstat. What do we have here? Okay, let's check it out. We have the lstat. Right? It calls lstat, and it checks a specific flag in lstat, and if that flag is set, it says, hey, go away, the file is a symbolic link. Right, so let's just take a look at what happens there. Of course, we can't do /flag. It says the path contains flag. So let's say, okay, we'll make a link to /flag / galf. Right, so now we have a galf right here. If we cat galf, of course we can't cat galf because we don't have permissions to it, but we can say give me galf, and it says nope, go away, it's a symbolic link. All right, so now what do we do? Obviously there's a race here. There is a check that happens, and then the program happily at a later time assumes that that file is now safe because hey, it checked it, right? But of course there's a race between the time of these checks and the time of this use. So let's exploit it in teaching mode for all of these levels. This is super easy because again, teaching mode will actually sit there, let you win the race, and then press enter when you're ready. So let's take a look. All right, so let's remove galf. We'll just make galf a normal file. Say okay, hit enter. Okay, and then so this is where it has now verified that it's not a symlink. Now it's happy. When we hit enter, it's gonna print out that file to us. We're gonna SSH in a different window. Okay. Here's galf. Now let's remove galf. And make it a symlink to the flag. We hit enter. Boom. It happily opens that file and outputs the flag. Of course, this is my flag. Don't steal it. Get your own flag. All right, so that was teaching. Teaching will block for you on all of these levels, or as many as it's reasonable, to make the race very explicit, to make you practice, to let you practice it. Let's take a look at a testing one that won't do that. Let's launch up testing. Boom. Inspect. It does the same thing, of course. We'll just verify it in Binary Ninja. Much simpler to read, of course. Here's that else stat. Here's that check if the string contains a flag. Of course, you can't really race this. It's just a check against memory, and you're not operating in this program's memory space. So this is what you race, and then it's very nice. It's nice enough to sleep for 10 seconds to help that race, and then you will. If you win this race, by the time it opens this file, it'll be a symlink. So let's take a look. SSH back in. Okay, here's my galf file. All right, let's say okay. Give me galf. Says nope. File is a symlink. All right, let's remove galf. Make galf a normal file. Okay, that works. Why doesn't it sleep, Connor? Oh, it's nano sleep. Sorry. Yeah, so it's sleeping for a very small amount of time. It's sleeping for 10 milliseconds. Okay, cool. So it's just enough to make that race more winnable, but not enough for me to switch over and do what I did with testing mode. So what do I do? Of course, what I do is run this on repeat. Okay. And grab for the flag. In another terminal, on repeat, remove the gal file and symlink the gal file to /flag. Boom. It's not going to be happy because now, of course, the file is symbolic link. And in a third terminal, I make the file, remove that, and make the file normal again. So what this is going to do is make Galf flip-flop between being a symbolic link, not existing at all, which isn't really what I want, and being a normal file. And if that flip-flop happens between the check and the use, we win. And eventually, if I run this in a loop, that will happen. And here it is. All right, so you can actually see, let's just remove this grep. You can see that it gets run tons of times. Often, our gal file just has the hi. Sometimes it doesn't exist at all because I just removed it. But every once in a while, sometimes it sees that it's a symlink and doesn't like us. But every once in a while, when it checks, the file is a normal file that says hi, has hi in it. And when it actually goes to open it, it's now a symlink. And we get the flag. All right. Yeah, so doing this in Tmux will be perfectly fine. I use screen just out of personal preference. So the question on Zoom was, can you open just different terminals instead of using screen or Tmux? Yes, absolutely. It's all the same. Yeah. Yeah, so the 3 commands that I use, I have a one bash one-liner that just loops and continuously launches the program with galf as an input. I have another terminal that is looping and continuously removing the galf file and linking the galf file to /flag, making that symbolic link. And I have a third, what's it called? A third terminal that is looping, removing the gal file, and replacing it with a normal file. So ideally, this runs right before the check. This runs right before the use. And then this gives me the flag. So yeah, on Twitch, someone's asking, could this be done in threads in a Python script? Absolutely, yes. Yeah, and I agree actually with what Connor just said in Twitch. os.fork in Python is by far the easiest way to multiprocess in Python. You can, if you're writing production software, use multiprocessing. If you're writing a hacking thing, import OS. Oh yeah, and IPython, let's see. Yeah, it might. This might crash my IPython. Okay. Yes. Okay, but if we have an x dot, if we have a y.py, import OS. If it's not 0, the parent. Boom. Super easy multiprocessing. And of course, if you call os.fork twice, now we have 4 processes running. This is an incredible way to multiprocess. You can even do insane things like, based on the values of these, give yourself an ID. Well, actually, this is stupid. Here we go. Oh, what am I doing? Just randomly executed something from my history. Here we go. There's your PID. This is, I would say, for hackers, the right way to multiprocess. So there's a question, how long should it take approximately? I mean, you just saw my exploit. It was almost, I won the race almost immediately. Yeah, so question about the bash script history. Here it is. So I run the command over and over. At the same time, I have one script that is constantly symbolically linking galf to flag, and one script that's replacing it with a normal file. And then the thing that's running it over and over has various behavior, from giving me the flag to failing to even check the file because it doesn't exist at the moment, to giving me the high content in the file, to complaining that it's a symbolic link. But every once in a while, as you can see, very frequently, it gives me the flag. Yeah, and then of course level 2, as we were talking in Twitch, level 1 sleeps. This radically increases your window of opportunity. Level 2 doesn't sleep. If you're having trouble, that's where the Filesystem Maze can come in useful. All right, let's take a look at how people are doing. We have 6 solves for level 1, 16 solves for level 1 teaching. Level 2 testing 1 still has 0 solves. All right. Right, so the question, there was just a question on Zoom. In level 1, there's the galf file. That is a file that I created. So baby race takes a file name that will print out to you. Etsy password, boom, it printed out Etsy password. But it won't allow you to do /flag, and it won't allow you to do a symbolic link. So what do you do? Of course, the trick is winning a race with the file, switching out the file that it's about to read with a symbolic link. I named that file galf. It's flag backwards. And basically, I just keep swapping out galf between being a normal file and being a symbolic link. Galf is an arbitrary name. Oftentimes, by the way, in these situations, I see there's some what's the term that I'm trying to think of? There is some despair on Twitch about copy pasting the flag out of tmux. Oftentimes in this situation where you're running things a million times and so forth, make it easy on yourself and tee it to a file, save all your output, and in fact save all the error output too. Boom. Now everything is in this output file and you can calmly grep it for the flag. So there's a question on Twitch: are most of these challenges something we can pull off with Bash, or are they going to require Python in the future, in later challenges? You'll probably want to switch over to Python in the later ones. Let me show you how I would approach this one in Python. So let's do this. Will this work if I only have the parent print? No, just that os.fork is not going to fly. That's annoying that it can't do it in IPython, but let me show you in RPy. This is typically how I do things. Let's create a file called background loop. Have a command. And here we do a fork. Okay, here we do a fork. If we are the child, if you're the parent, sorry, we will return. Otherwise, if you're the child, we will loop and keep executing this command. Right? Nice and simple. We're going to do background loop rm galf, background loop ln-s/flag galf, and background loop echo hi to galf. Okay? And in the foreground, I'm going to use pwn tools to run let's kill this baby race level 1. Now, of course, this is being super lazy. I can do all of this in Python probably much faster than shelling out, right? All right, here we go. I'm going to need to kill. All right. Let's see if this works. my god. Oh my god. I forgot to kill the forked. Forgot to kill the forked things. Okay. Yeah, this is typically why you do stuff in like Pwn's tools or with actual multiprocessing libraries. This is a terrible advice that I gave you, but it works. All right, so we launch off some backgrounded loops, and then we're going to do this. And of course, I have now I'm redirecting all output out of here, so we don't see it. We don't need to see it. Okay, and we run, and here it is. Boom. And now we need to kill all this Python. Remember, if things get too out of hand and you accidentally fork bomb yourself or something, you can always restart your container. If you want to see how we would do this without Python, so we have, or without shelling out, we have background unlink, where we will, while true, os.unlink galf. So this is our rm galf. Boom, that's taken care of. We have a background link. I'm sure there's an import os.link. Yep. No, os.symlink. Yes. os.symlink. Source test. Okay. Background link. Okay, and we have a background right. And this is a we'll just not crash on any exceptions. And now instead of this, we just do background unlink. Remove these commands. Background link. And background right. And this will work just as well. Or not. Uh-oh, most of those crashed. Kill all the Pythons. All right, what happened here? Why is that long link galf should be perfectly... Oh, yeah, we want it to be. There's an awesome import context lib. You could do with context lib that suppress all exceptions. It's easy. It's less code than a try false. Boom. Or than a try except. Okay. And here we go. Boom. And we see it scrolling through. We scroll up. There it is. No shelling out. This code terrifies Connor, but it's good code. The awesome thing at the end, by the way, watch this. We do a try finally. When this process gets interrupted, when I control C or whatever, when this is all done running, this is gonna run, and here I just kill -9 all processes that I can kill. -1 means everything. So now I can run it, hit Control C. Oops, shit, that's not what I meant to do. It killed everything in the container. I think I just killed, okay, yeah. Not the intended result. Shit, where's my, okay. Screen went a little crazy with that, sorry about that. All right. If PID, yes, 0 is what I meant. 0 sends this to all children as well. Now, if we do y.py and we Control C it, it kills all of its children and nothing else to clean up. See, this is perfect. Highly recommend it. Oh, hold on. Can you repeat that? My audio went crazy. It'll be less than or equal to 15. We're still working on some of the advanced ones. So there's a question on Twitch. What is the command to kill all the Python processes? It didn't get saved. psax grep Python. Then I do awk to print out just the second one. The second column, which is the PID. And then xargs kill -9 will kill -9 all of them. pkill. Oh yeah, pkill also works. Pkill Python. There you go. All right. Anyways, alternatively, this guy's great. It'll kill all the children. You don't need to worry. If you feel that this is ugly here, then no problem. Put this in a main dude, and then here you do try main dude. Boom. I'm telling you, this is the way to do multiprocessing in Python. You want to see what's even more insane? Connor's commenting that this is insane. You have to be... you have to be very careful. If this doesn't loop forever, if it actually terminates, then you're in some trouble, because when Python terminates, it'll start cleaning up resources, and it might close things that are being used by your main thread. So just in case, obviously with while true it's not a problem, but if this wasn't the while true, you have to do this. You have to make sure to kill yourself, kill your process before it can like in os.exit. If you do exit, it calls libc's exit hooks. Actually, I'm not sure about _exit. That's a good question. I don't know, but this works great. We have a question on Zoom, how to switch screens. With Tmux, it's Control B, and then you release all buttons and then hit N, and that'll take you to the next screen. We can make this much nicer, actually. Check this out. Yeah, alright, see, now Connor's starting to believe. What? Yeah, but we don't always want to suppress. You know what I'm saying? Yeah. Okay. In my current code, we always want to suppress. All right. So let's do this. Let's do a background loop. Let's do this. Suppress loop. Okay. Boom. What do you think? It's pretty good. All right. Yep, it's still working though. That's incredible. All right. Let's see. How else can we make it better? Oh, I see what you're saying. So we suppress and add a lambda here. This is terrifying. I don't have enough parentheses. Okay. This won't work though with it. Can I have a width in a lambda? I don't think so. No, we can do this with this guy, of course. With the open. We don't need all that open. So we can do this. No, we don't need a width. We just need to open and close. Yeah. I don't know how to save it. That's terrifying. Hold on. Ah, I know. Check this out. Okay, here we go, times 2. Now we have 2 of these guys.
Is there something else I can help with?
Siri just triggered. Oh, what? I mean, I could just do a close on this guy, right? It's... Okay, this is going to be insane, but okay, lamb. What? Oh, because basically I don't need to write anything to it. Yeah, I just need it to exist. All right, but that's kind of cheating a little bit. We didn't. Yeah, it's slightly different code, but I think we could still write something to it if you were crazy. Oh, sorry. Yeah, you're right. Okay. Dot close. Okay. Still works. There's the flag scrolling by. Amazing. All right. Not bad. Not bad. Ooh. Can write it in Yan 85. All right. Yeah, so this right here is basically about 8 times better than the multiprocessing module. Oh, on Zoom, how to switch screens with screen. That's Control A instead of Control B. Screen was the original. And used Control A, and then Tmux came about and said, well, we'll just copy everything that screen does, but change it. Control B. This is insane. Yeah, interrupts, as we'll talk about in the next lecture tonight, interrupts are catching signals in threads is really hit and miss. It's going to be tough to... sorry, everyone on Twitch, Connor was talking to me about handling Control-C in this crazy homespun multiprocessing. Anyways, every single time I've used multiprocessing, I've had tons of issues, and it's been horribly painful. This might fork bomb your machine once or twice, but other than that, it's great. Yeah, I'm running this in my home directory. But I can run it from anywhere if I change, the Galf path to be... one very important thing that actually I forgot to mention. Because of these exact situations, there is a special thing that in /temp or in any directory that has the same permissions as /temp. /temp has this special bit for its directory. You cannot, root will not follow symbolic links that are not owned by root, right? So Galf can be in a lot of places. It cannot be, so it can be in home CT. Let's actually make this file name. So right now I have it in home CTF Galf, and this works great. So, okay, you see the flag scrolling by, awesome. I can put it in a lot of places. I cannot put it in /temp. The challenge will not follow symbolic links, or root will not be able to follow symbolic links. It'll get permission denied if they're owned by your user. So you see I'm running it right now with temp Galf, and I am not getting any flags. That might be why people are having trouble on Twitch, actually. Don't try to do this in temp. Yeah, I forgot to, I should add that as a, Let me add this as a slide to the lecture so I remember to. Okay, the bash loop T in a file. Someone's asking. Man, I lost it. Okay, so while true, do the command, done, and then T that whole thing into a file. Boom. Okay. Made a note there. All right, let's check in, see if anyone has solved level 2 yet. Ooh, 4 people. Awesome. Ha! Freak Mod, Saul got first blood on 2. Aaron got second. L1R got third. O1 got fourth blood. Level 3, 3 solves. Nice. Freak Mod got first blood. Level 4, no solves yet. All right. Amazing. Wait, Connor, has WCTF started? Are you playing WCTF right now? Whoa. Whoa, hold on. Forg just got first blooded? Nope. Oh yeah, the teaching assault. Sure. First blood is the testing. The teaching lets you pause the thing. Awesome. Ah, this is fast. These hackers are fast. Wait, so how long has WCTF been live? Oh, only an hour, okay. Oh, first blood on level 4. Frick Mod dethroned. Nice, good job. wants that throne back. It's so cool to see how many people are doing so, like, I mean, hundreds of flags in this class people have gotten. It's incredible. You know what would be awesome? We should just package this up in a easy MP library and actually put it on pip. Let's do it. What's a nice example setup.py? This crazy thing. It is a Python wrapper around parallel. It's because parallel is the best, man. Just like EasyMP is gonna be. Yeah, this is gonna be great. Multi-processing done right. We could also do threads. We can just do os.clone. Just like hijack Python. All right. Here we go. Wait. PyMod. Yeah, okay. No, it'll call the function. Don't you want the background decorator? Let's use it. Background decorator. Oh, interesting. There you go. It already works. All right. So we have the suppress loop. Let's just add some sugar, syntactic sugar here. Okay. Mm-hmm. Oh, in here? That's all you need. Wait, this will be hard with the decorator, won't it? How do you have a decorator? Yeah. Okay. Yeah. Inside here. Oh, I see. So there's an inner function here. Yeah. Yeah. Let's just make it easy. If suppress. I'm sure there are way better ways to do this, but awesome. Oops, I forgot the width. Oh, well, that's incredible. So by default, we have suppressed none. Okay. No, we don't need to test that by. Just if name equals main. Boom. Yeah, man. All right. So I guess what we should do is this. And this. Yeah. What does the walrus operator even do? Oh, I see what you're saying. Okay. Sorry, I thought you were talking about the matrix operator thing. Okay. Cool. All right, but I don't like. Okay, so this is a decorator that immediately runs your thing. This is a decorator that also immediately runs your thing, but there's no backgrounding that's happening here. Something is wrong. Yeah. No, but this... No. No. Yeah, but this will do background in the loop. We want background to be done outside of the loop. What we want is... Here. This is what we want. We want a loop it. And here... I'm sorry? Yeah. Here? This one? Oh, you're right. Yes, thank you. Okay. And def. This guy is going to suppress inner. No. This is a little different. Okay. This, and then right. And so now we can suppress inner. No, sorry, suppress exception, loop it. Oh yeah. Sorry, go ahead. Questions about the class obviously override this insanity. Yeah, so the question on Zoom is conceptually, what's a good way to approach these challenges, right? The first step of every race condition challenge is to understand where the vulnerable window is, right? So, and actually that's the second step. The first step is to understand what can you impact the process with, right? Can you modify, do you share a file system? In all these cases you do, right? Do you share memory with that vulnerable process? Or can you impact its memory through a different thread? In this case, in level 1 and 2, and most of these you don't, but some of them you do, right? Think through that, and then when you've identified the ways that you can impact it, identify the window during which you can impact it. It's a good question. Yeah, here's what I can do. If this doesn't run it, if I just okay. Now yeah, we can always have another guy that background run. That's true. We can tackle that later. In terms of conceptual approaches to the race conditions, did that help? For example, yes. The memory part is thread exclusive. Yeah. Killing with 0, like this, just tells you is that process alive or not. It'll assert, yeah, it'll assert in Python and return an error in C. All right, we're at the end of the class time. Any questions from Twitch, from Zoom about race conditions, or are we rolling forward? Let's see what the state of the challenges are. Anyone else solve? Ooh, second solve for level 4. Blue shirt Jan, but cooler. Level 5 is still unsolved. Nice. What's your question? So the question was how to approach writing a Pwn tools script when you're dealing with like a multi-threaded process. It's tricky, right? So you're going to there are two options. One, you can write multiple scripts and run them in different sessions, right, in different terminals. One script that does one action, the other script that does another action, etc. The other way is basically this, right? In the background, you do one action, and in the main thread you do another action, right? Essentially, yeah. Alternatively, sometimes you can even just do a normal Python process that just, let's say opens up 2 connections to the server and just loops through and sends stuff on both connections. Mm-hmm. Yeah. 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 Exactly. You open up 2 terminals and do things on both. Hold on. Oh, good. So the question for those on Twitch is, it's unclear how you would trigger behavior of different of different threads from your Python attack script, right? It really depends on the program, right? So for some programs, for example, in my data races lecture, there's a program where both threads are reading from standard input, right? So just by writing to standard input, you're interacting with both threads, whichever happens to be reading at that time. Most of the time, programs aren't like this. So programs most of the time will have a network connection open, right? They will spin off a thread to handle a new, or they'll have a network server. They'll handle a spin off a thread to handle a network connection. And so when you talk over that connection to the challenge, you will be directly triggering actions in the thread that's handling your connection. Some of the later baby mems are like this with multiprocessing, but multi-threading and multiprocessing are very similar, right? It's just a matter of sharing the memory space or not. and some other things. There are also some of the baby ROPs. The later baby ROPs are like this. And some of the later baby revs. Maybe not. No. One of the later baby. Do you remember, Connor? Is it a baby rev or a baby jail that we have for things where we can practice interacting with multi-processed things? Anyways, for sure. Yeah, the last baby mem, and then I think the last baby ROP as well. All right. Let's call that a day. Good luck. We'll launch another lecture tonight, another lecture video, 20 minutes or so, and then, not in 20 minutes, but 20 minutes long. And then more processes, more challenges. Connor will have his office hours on Friday. I'll have my office hours on Monday. And on Wednesday, we'll move on to baby kernel. Sorry, toddler 2. Yeah, one more. What's up? Yes, exactly. Symlink creates a link to any file you're choosing. Yeah, so the question is, why was Symlink created? It's very useful to be able to reorganize data without moving it. That's what Symlink does, right? A symbolic link basically allows you to have, you know, I mean, here's an example, right? If you look at VI, right? VI, the text editor. VI is in user bin VI, but that's a symlink to Etsy alternatives VI, because there are many different VI alternatives that might be installed on a system. There are many different flavors of VI. There's VI, there's Vim, there's NVI, there's NeoVim, there's a bunch. If you look at Etsy alternatives VI, right now it's set to Etsy bin vim.basic, which is the actual binary. Of course, I can just not worry about it, type VI, and get into this vim.basic. But I can also, using some Ubuntu, well, Debian or Ubuntu or whatever we happen to be running here, I think Ubuntu commands, change this symbolic link to point to a different VI distribution, right? A different VI flavor. So that makes symbolic links very useful. Cool. All right, everybody. Thank you for tuning in. Any questions you got, talk to us on Discord or email, ideally in the help channel if it's for help. So then other students can help and benefit from answers. If you are asking on the help channel but aren't getting a lot of luck, feel free to tag us in, just at Zardus or at Kanak. Please use the what's it called? The collaboration rooms. The collaboration rooms are open for a reason. Use them to collaborate, and good luck. See you later. Bye.